Today we are doing implicit differentiation number 2. We are looking at some other examples to find the derivative of an equation, and we're also going to find the slope of a tangent line. Let's take a look at the warm-up. I want to do the derivative of y squared, which is 2y times dy over dx. Then I do the derivative of minus 2x, which would be minus 2. And then I do the derivative of y, which is 1 times dy over dx. Notice that I have a dy over dx on opposite sides. You need to get them on the same side so that you can isolate them. What I would recommend is that you subtract the the 1 dy over dx and put it on the left-hand side, and add the 2 and put it on the right-hand side. So you would have 2y times dy over dx minus 1 times dy over dx equals a positive 2. Since you have two terms that involve the dy over the dx, you need to factor that out. So I'm going to factor out a dy over dx from both terms, and the remaining factor is 2y minus 1. And the last step would be to divide both sides by 2y minus 1. That's your final answer. In example number 1, we have 3 terms on the left side and 1 term on the right side. You want to take the derivative of x cubed, which is 3x squared. Take the derivative of xy, which is a product, so we have to use the product rule. Set up your template and put down 4 parentheses. 1 for f prime, 1 for g, 1 for g prime, and 1 for f. F prime would be 1, g prime would be y, g prime would be technically 1 times dy over dx, but I'm just going to write dy over dx, and f is x. Then I have to take the derivative of y cubed, which is 3y squared, times dy over dx, equals the derivative of 1, which is 0. Let me draw a little line here so that we don't get confused with the previous problem. Now I have 4 terms: 3x squared, 1y, dy over dx times x, and 3y squared times dy over dx on the left-hand side. I'm going to move 3x squared and 1y to the opposite side, so that becomes negative 3x squared minus y. And at the same time, I'm going to factor out on the left-hand side the dy over dx, and that leaves x plus 3y squared. And my last and final step would be to isolate the dy over the dx by dividing both sides by x plus 3y squared. And there's your answer. If you get a similar answer, but it's positive 3x squared, positive y over negative x minus 3y squared, that's the same answer. It's equivalent. All equivalent answers would be accepted. Going on to example number 2, I hope you guys are keeping up and taking notes and paying attention. In this problem, we have 2 terms on the left and 1 term on the right. This is a product rule. I'm going to separate it as x squared times y. So hopefully you're getting in the groove and remembering to set up your template when you're doing the product rule. So this would be f prime, which would be 2x, g would be y, You don't need to multiply that by dy over dx. Then you do g prime, which is dy over dx, times f, which is x squared, plus, now I'm doing the derivative of the sine. The derivative of the cosine, if you recall, is, the derivative of the sine is the cosine, but you also have to multiply by dy over dx because this term involved a y, equals, the derivative of 2 pi is simply 0 because that's a number. So I have two expressions that involve a dy over dx, so I'm going to move the 2xy to the other side, and that makes that a negative 2xy. And on the left hand side, I'm going to factor out the dy over dx, and that leaves x squared plus the cosine of y. And then you just simply divide both sides by what's inside the parentheses. So that gives you negative 2xy over x squared plus the cosine of y. I'll give you a minute to make sure you're finished copying, or a second, I should say. Don't be afraid to go on Edline and check out the video. I'll have it on my Edline page under links. So if you want to watch it again, you can watch it again. I know you're just dying to watch a YouTube video about math. Example number 3. You have 3 terms that we need to take the derivative of. The derivative of x squared is 2x. The derivative of 4y is 4 times dy over dx. And the derivative of y squared is 2y times dy over dx. Remember what I told you yesterday. The first step that you're taking is calculus, and everything after that is algebra. So it's a matter of factoring, adding like terms, combining like terms, multiplying, dividing, subtracting. In this case, we are going to factor, since we have 2 terms, with the dy over dx, we need to factor that out, and that leaves 4 minus 2y. And then the last step would be to divide both sides by 4 minus 2y. Now this is not completely simplified, so what you want to do is to take out a value of 2, since that's what the common factor is. You would say 2 goes into itself once, into 4 twice, and into 2 once. You need to be able to take the factor out of everything. So the final answer, dy over dx, is 1x over 2 minus y. And that's your final answer. Of course, any equivalent answer, if you had negative x over positive y minus 2, that's the same thing. So be aware that all equivalent answers will be accepted. And now the other part of the objective, in example 4, it's asking you to find the slope of the tangent line to the graph of y squared minus 2x equals y. And I did this on purpose. This problem is the same as your warm-up, so that we don't have to spend time doing another derivative. I'm going to go ahead and take the answer from your warm-up, which was y prime equals 2 over 2y minus 1. And once you have the derivative, if you want to find the slope at a specific point, you are going to substitute, in this case, 1 for x and y, negative 1 for y. But if you'll notice that in your derivative there isn't an x, so you don't need to substitute the x. All you have to do is substitute the y. So I plugged negative 1 in for y, and I just merely find the final answer. 2 times negative 1 is negative 2, minus 1 is negative 3. So the slope of my tangent line at the ordered pair 1, -1 is equal to -2/3. So that's part of your objective. The other part of the objective is actually finding the equation of the tangent line, and we're going to be doing that in example 5. Again, to save time, I used a problem that we've already found the derivative. This problem is the same as example number 2. So I'm going to start with the derivative from example number 2, which is y prime is equal to -2xy over x squared plus the cosine of y. I'm going to substitute 1 for x and 2 pi for y. Don't be concerned that one of the values is 2 pi. You certainly can use your calculator, and you want to be in radian mode, but I don't really think you're going to need it. If I substitute 1 here, and then 2 pi for y, and then 1 squared plus the cosine of 2 pi. Now, if you don't remember, well, let's simplify the numerator first. That's going to give you -4 pi, and this will give you 1 plus. If you don't remember what the cosine of 2 pi is, you can certainly do that on your calculator, but it happens to be 1. So if I simplify this, I have -4 pi over 2, which gives me -2 pi. So that's my slope. And I have my ordered pair 1, 2 pi. To write the equation of the tangent line, you need to use the formula y minus y1 equals m times the quantity x minus x1. And we're going to plug in 2 pi for y1. We're going to plug in -2 pi for m, that's what we just got, and we're going to plug in 1 for x. Using the distributive property, you get -2 pi x plus a positive 2 pi, and then we want to add this 2 pi to both sides. So the final answer is y is equal to -2 pi x plus 4 pi. Okay, so now it's your turn. You have problems on the back of your class notes to do with the answers, and I need everyone to do their classwork, and if you don't finish in class, finish it for homework and bring it in Monday. So have a nice weekend, and I'll see you guys Monday.